In my previous video, I mentioned that there will be two special triangles in trigonometry. These two are the main characters of the topic and are actually traceable in the unit circle. These are the 45, 45, 90 triangles and the 30, 60, 90 triangles. They are also called special triangles because once you know the angles, the side ratios are fixed. Knowing one side tells you all the others. Now let's focus on the isosceles right triangle. Because the two angles are equal, the two legs that are connected by the 90-degree angle are also equal. Those two legs are the x and y distances from the origin, and in the unit circle, the hypotenuse always has a length of 1, as this is an idealized circle of a radius of 1 unit. But I will explain more about the length of each side of these triangles on my next video. For now, let's look into the first quarter of the unit circle and see how this triangle is directly extracted from here. Zooming in, we can see that the radius makes a 45-degree angle with the x-axis, and here another 45 degrees with the y-axis and the hypotenuse. And here, of course, we have the 90-degree angle from a perfect intersection of the y and x-axis. And so this triangle is found when we rotate 45 degrees inside the circle. As we can see, it is exactly halfway of a quarter of the circle. And now let's move on to the half equilateral triangle. This triangle comes from cutting an equilateral triangle in half. If I cut this triangle with a straight line, I create two 90-degree angles and divide this 60-degree angle into 30 degrees here and 30 here. Hence why we get a half equilateral triangle. Let's dive into the unit circle again and see where this fits. Looking here, we see that there is a 30-degree angle from the radius and the x-axis, and a 60-degree angle separating the radius and y-axis, and of course, the 90-degree angle. And rotating to a 60-degree angle, we find this triangle again. The roles of the legs swap, but this is the same triangle. So this triangle is found naturally at 60 degrees and also at 30 degrees, dividing the circle symmetrically. So this is why trig is not random and the unit circle is a powerful geometric tool, and understanding it deeply shortens our calculations and gives real meaning to trigonometry.